Hello and welcome to this channel. In today's math tutorial, we want to solve this trigonometric equation 7 to the power of cos square x plus 7 to the power of sine square x equals to a. First, we are going to be using the trigonometric identity where sine square x plus cos square x is 1, so that we can write cos square x from that identity as 1 minus sine square x, so that the trigonometric equation becomes 7 to the power of 1 minus sine square x plus 7 to the power of sine square x equals to a. Then the exponent 1 minus sine square x can be written as 7 to the power of 1 divided by 7 to the power of sine square x, and that's plus 7 sine square x is equal to a. We multiply through by 7 to the power of sine square x to give us 7 plus 7 to the power of sine square x all squared, and on the right hand side we have 8 times 7 to the power of sine square x. Now at this point we can let 7 to the power of sine square x be y. This leaves us with 7 plus y squared equals to 8y. Then reorganizing this quadratic equation will give us y squared minus 8y plus 7 equals to 0. And with the constant term being plus 7 and the middle term being negative 8, then minus 1 and minus 7 are the factors to use in factoring this. And when factored, it is going to be y minus 1 times y minus 7 equals to 0. And by the zero product property, y minus 1 is 0, or y minus 7 is 0. So that y is either 1 or y is 7. Now that the values of y are known, we can go back to the transformation we made earlier, where we said 7 to the power of sine square x should be y. Now we'll be considering the two situations, which are when y is 1 and when y is 7. When y is 1, then 7 to the power of sine square x is 1, and note that 1 can be expressed as 7 to the power of 0, so that 7 to the power of sine square x is 7 to the power of 0. Equating the exponent gives sine square x equals to 0, and taking the square root gives sine x to be 0. Now we also consider when y is 7 to know what sine x is going to be. 7 to the power of sine square x is going to be 7, and 7 can be written to power 1. Equating the exponent also will give us sine square x equals to 1. Then we take the square root of both sides to have the square root of sine square x equals to plus or minus the square root of 1. And this shows that sine x is plus or minus 1. We now have three different values for sine x. We've got 0, negative 1, and positive 1. In those three situations, we're going to take the sine inverse of 0, of negative 1, and 1 in order to get the values of x. When sine x is 0, then x is going to be the sine inverse of 0, and the sine inverse of 0 is 0. So x will be 0 degrees as the angle to start with. Now, at every 180 degrees turn, x will always be 0. Every addition or subtraction of 180 degrees to the angle 0 degrees that we started with is going to give us the sign to be 0. Therefore, in degrees, we can write generally that x is 180 k degrees, where k is an integer, or in radians, we can write generally that x is equal to 180 is pi, so this is k pi radians. And again, k is an integer. When sine x is positive 1, x is going to be the sine inverse of positive 1. And for sine inverse of positive 1, the starting angle is 90 degrees. Now that the starting angle is 90 degrees, then for every 360 degrees addition or subtraction to the 90 degrees or the subsequent values, the value of the sine will always be positive 1. Therefore, in degrees, we can write generally that x is the sum of 90 as the starting angle and 360 k degrees, where k is an integer. Or in radians, we can write that x is 90, which is pi over 4, plus 360, which is 2 pi, that is 2k pi in radians. K is an integer. And thirdly, when sine x is negative 1, then x is going to be the sine inverse of negative 1. And the starting angle for the sine inverse of negative 1 is when the angle is 270 degrees. So as usual, with 270 degrees as the starting angle, every addition or subtraction of 360 degrees will always make the value of sine x to be negative 1. Therefore, we can write in degrees that x is 270 degrees plus 360 k degrees. Still, k is an integer. In radians, we can say that x is 270 being 3 over 4 pi plus 360 k degrees is going to be 2k pi in radians. K is an integer. In conclusion, we can write the possible values of x for the equation as in degrees, x is 180 k degrees, x is also 90 degrees plus 360 k degrees, and x is also 270 degrees plus 360 k degrees, where k is an integer to accommodate both positive and negative angles. And in radians, x could take any of these angles, k pi radians, x could be pi over 4 plus 2k pi radians, and x could be 3 pi over 4 plus 2k pi radians. K is an integer. I believe you enjoyed the tutorial. Please give the video a like, help us share it, and make sure you subscribe to this channel. Click on the notification bell so that you don't miss any updates and our latest math tutorials even from this channel. Thank you for watching this video. Bye.